Well, good morning or afternoon or evening, whenever you're watching this video. Um, Last time I had one of those little marble machines, and this time I've been working on one of these little robots. Um, I'm gonna in notes below. You're gonna have um, a, a shortcut or search on GitHub for all the files you need for this little robot. I'm not a very good. I actually should say I am horrible in programming, and so I use Chat GPT, and I was after a few days able to make the version that I'm gonna upload or is already uploaded on GitHub. And so this little robot is not very difficult to make. I also will have there all the parts you need, and then some of them you might already have, some you might want to buy, and some you want to maybe make. And so I made it in a way that you can hopefully figure it out just like I did, how to make it go. As long as you wire the wires correctly, you should be able to make this robot work pretty well. Okay, so I bought, actually some times ago, I bought this plastic, let's call it the frame of the robot, and then it came with two wheels and two motors. Okay, and it came with a switch, and it came with a battery pack. I think this one is it. It came with this battery pack, and so I like these 18650 batteries. They last way longer, and they are rechargeable, and I like that. I hate to buy batteries and then they cannot be recharged, and on some projects the rechargeable batteries, even if you use that battery holder like this one and put in rechargeable batteries, they are not usually 1.5 volts, so it drops down 4 times half a volt, so 2 volts, and that sometimes would not make it work at all. So, but as long as you use regular batteries, it'll work. So what I did is I'm going to turn it upside down and show you how I did this. So first of all, I solder always the leads onto the motor. Okay, and you can also use a little zip tie. Sometimes it comes with a zip tie, so the wires are pinched underneath the zip tie. Here's a good example. Okay, and so that's more safety, so you don't yank them out. The next thing I had to do is I had to install this little bracket that comes from this side. This little, it looks like a T, and it goes through this plastic thing, and there's two of them, one on each side, and then there's two bolts with a little nuts, and then you screw it in. Now, since it's transparent, let me show you what that looks like. Okay, so they look like this. These I made on a laser cutter. I designed this and made it work. So if you have a laser cutter and you like to make them out of wood, that's fine. Whatever makes it go. Okay. Hot glue is okay. If you make some kind of a shape and then drill a couple holes, and then you have a base. So it's not difficult. I'm gonna upload also in and it's not in this video, but in my next video, in a frame like this one, but it's going to be a little bit longer, a little bit bigger. Let me just kind of give you a little preview. It won't even fit the video. There we go. So what I did is I copied some of the stuff from an existing picture and then I had to, of course, resize and straighten up and make the holes a little bigger and stuff like that. So this is going to be my next project, and I'll upload this frame so you can literally, if you have a laser cutter, you can literally cut a different shape or customize it any way you like. Alright, so that's for next time. Okay, so then this little caster that came with this plastic base has a little stands up or stands, and then you just screw them in and you put the caster on, and the caster is there so if this makes a tight turn, it can make a much tighter turn usually than the other one I was just showing. Now what you're going to need is, after you have some kind of a battery and the switch wired, then test with the switch or another switch you can use, test if these two motors are spinning the same direction. If not, what you have to do is you have to and flip the polarities on one of the motors to match the other motor. So if this one goes forward and this one goes backwards, that way it's going to be just turning. You can make one of the motors follow this motor or that one just by flipping the plus and minus, which is the red and a white wire or red and a black wire, depending on what wires you're using. Okay. The next thing, after you have that working, then I would install Arduino, which looks like this. And once you install it in its place, then on top goes this motor driver kit, and it just directly plugs in, so it becomes one unit. Okay, so that's pretty straightforward. Okay, we don't really have to worry that much. What I did, you see probably this little white, it's white putty, but it's a special putty. It's not it's not a plumber's putty. It's called plastic tack. I bought it on Amazon, and they come in different packages, different lengths. And the reason I use those is I'm not sure if this thing is the final thing. So the battery pack, as you can see, is held by 4 of those. In here I have a screw, but I just used one. One bolt and nut, and then I put the putty on both sides so it's not getting crooked, because I just had one screw there, Now the Arduino, again, I hold it with the putty in its place, and it's staying pretty good. I've been working on this for a while, and so if you want to go that route, you can, or you can use also Velcro, so you can get like stuff like this, and it's indoor outdoor, and they come together like this, and they are very sticky backs, I'm sorry, and they are really tough, so you don't have to use much Velcro to hold like the battery or the Arduino. But as you can see, it just splits like that. One side is the side A, and one side is the side B. Okay, and I usually cut it to the lengths. I sometimes also just make strips, because as I said, this thing is really, really good. Really, really good Velcro. Okay. Now, so now we have the motors installed, the battery pack, the switch, which turns on and off the power. Okay. Then we put the Arduino on and snapped on this motor driver, and then we take the 2 wires from this motor and put it on this side. Okay, and then this motor, as you can see, the wire comes out, goes to this side. Okay, so once you have the motors connected, then can pretty much so upload my program. Unfortunately, the sonar and the little servo here, which is down here, and it rotates this left and right, they ain't going to be working it until you connect them, which is not very difficult. So you can hot glue the little servo directly to this, okay, or attach it some other ways, or you can use the putty, or, and I'm including that in the file, this is a little holder for these little servos, and they are not completely, you can actually remove this if I pull on it hard enough. So I made it nice and tight, and you can print it, and the file is included. So let me get some water. I'm getting a little dry. Now, there are 4 wires that are going out of this sonar, and so you don't have to like trying to figure out what goes where. As you can see, if you follow the color, in this case this is white wire and blue wire, and then this lavender, whatever, it's this purple, and then the green wire, okay, and they go all the way to this side of the motor controller. And in my case, I soldered a little headers in here, so because I hate to solder on directly onto the controller or Arduino, so I always put headers if I can. And basically they are females, so these wires that have a pin out that it just plugs in. And you don't have to do all 3 rows or even the ones over here. You just need to do these first 3 layers, okay, or solder it. It's up to you, because as you can see, there's only 4 wires that are going to these 2 these 3 connectors. The first one and the second one, I'm counting from inside out. You have a 5 volt is the first one, so the yellow wire in this case that goes in here, I'm sorry, white wire, goes to a positive 5 volts. Green one is ground, and then you have these 2 pins, which is which goes the brown or the whatever color it is. I have a hard time deciding. It goes to this connector here. Okay, now I'm going to try to go closer. There we go. And then the first pin is free. Then the next pin, because that's a pin 0, so this brownish whatever color it is goes to the second hole, and right next to it goes the blue wire, and they basically the data wires. And if the sensor doesn't work, maybe you flip these 2 around, so you cannot do a damage. So if you miswire this, that's all 5 volts, and so that's going to be okay. So now the last thing you need to plug in is the servo, which is this little guy, right? This little servo. And basically the only thing you have to do is, as those 3 wires are going somewhere, on left upper side of this controller are 2 rows of 3 pins. And in my case, I'm using the closest one to the center, but again, if you put it on the other, it just won't work. And the only thing I have to watch for is make sure that this yellow wire is on towards the inside. Okay, so it's plugged in like that, and that the brown wire is on the very outside. Okay, and then what you do is you take a USB wire, right? Just A and a B it's called, and this goes to the computer, and this thing here plugs into here like that. And then at this point you should have on a computer Arduino IDE, which is a free programming software for Arduino. My meds make me really dry, I apologize. Okay, so then what you do is you upload the code after you open it up from the downloads that you're going to do from my GitHub account, and you're going to then unzip it, or some files are just the way they are, and then you can just upload your sketch. And once you upload it to the Arduino, unplug the cord and then turn the switch on. You shouldn't have the cord and that switch on at the same time. So this is for programming, okay, and this is to run the whole thing, okay. And so as you can see, if I turn it on, it immediately goes forward. And then you see what I did is I put a hand in there, and then now the robot is basically turning around and tries to get out of the dead zone, let's call it that way. Okay. Now one more thing that I discovered, and I don't know if it's this computer, this laptop I'm using in this case, made by a company called MSI. I love this computer, but I don't know if it's something's going on with the USB ports, because now all these newer computers, they're protecting the USB ports because they are USB 3 or 3.1, and so they are, it's called managed. And so sometimes when I plug this cord in, this Arduino does not want to stay open, okay, in other words, available. And I've discovered that this, in my case, yellow little jumper, and this, what this jumper does is, this jumper, if you have it like that, that means that the battery power goes to this board, and then this board sends that power also to the Arduino, because you have to have both of them on to make it work correctly. But when you are trying to like upload a sketch, as it's called, and it doesn't want to work, just unplug this little jumper, and I usually put it on the single pin, and then I upload everything. When I'm happy, I unplug it, I take this pin and cross the two again like they were originally. Whoa, look at my camera. Oh, kind of funny. Anyway, and so then it will work. It might just happen once or twice, and I don't know if it has something to do with the firmware or whatever, but that's just something I discovered. At first I thought I had a bad Arduino, but I replaced the Arduino, replaced the motor drive, and this board here, and I couldn't make it work. And so then I figured out that it's a small tiny bug that doesn't always gets in its way. So anyway, I actually made a video yesterday, and I was going to upload it last night, and unfortunately I used my GitHub account shortcut, and what happened was that the GitHub didn't make it through, because as I'm uploading it to the YouTube, and the video is there, I type in the notes and then all the stuff which you can follow, and then I put my GitHub account that you can download from all the files that I put in there, including and a STL file for the 3D printer, so you can print this little holder if that's what you want, and you can redesign it, by the way. And then if you have a laser cutter, then this little housing I also uploaded, so if you have a laser cutter, you can cut it, or you can make STL files following the dimensions, and then you can I guess you can create your own, and then if you have a 3D printer, 3D print it. One thing I would recommend is to not to glue. You can glue the floor, both sides and the front, and then the rear of this little sonic holder. I made it so basically this thing. Let me just put it down. Very difficult to do with one hand. I made it so you can actually unplug. It's nice and tight, and I like it that way. It just takes. There we go. So basically, what's happening is this piece comes out, and the reason I did that, so this stays put, and if I glued it, then I could never remove this, easily remove it. I would have to, cut things out and possibly even damage the little board. So I would strongly recommend that if you make a cover like I did, like this one, the back side of the box basically, or make it wider. If you design it in your, like let's say Fusion 360 or whatever, and give it enough room that you can actually slide this out and reuse it again. Because some of these projects will stay put together for a long time, and some of these projects will be taken apart and used for different projects. So that will do that. Okay. Now, what else can I tell you that to watch for when you test this? Put a bunch of like boxes in a U-shaped, kind of make it look like a tunnel, and then and the one end will have one big box at the end or a couple, and then this is the front of the robot. So this goes forward, and as soon as this sonar ultrasonic detector, let's call it, or distance meter, as soon as it's like 20 centimeters, then it will stop, and then it will try to look left and right with this little tiny servo. It will rotate left and right and finds out where there is a way to go, and if not, it will try to turn a little bit, do it again, and so on until it gets itself rotated to the area that does not reflect back the ultrasonic sound. So by the way, it's a very simple. It's one is a speaker and the other is a detector, and the sound is in a frequency that we cannot hear. Okay, so it's just like a laser light, non-colored. You just can't see it. Okay, so if you have any questions, feel free to ask me, and if I can help you, I will help you. Otherwise than that, have fun with this mainly. And what I'll do is, just in case that I'm going to have trouble with the GitHub, let me go to the GitHub page. There we go. So basically, what you can do is go to github.com, and then you will search for check T, which is let me sip of water. C like Charlie, Z like zebra, E like echo, C like Charlie, H like house, and T like today, tomorrow, and then / 2WD hyphen sonar hyphen robot, and then CHAT, which the robot CHAT is together. Okay, one more time. Check T / 2WD hyphen sonar hyphen robot chat. Okay, because I used Chat GPT to help me to program the robot, because all the ones I found on the internet weren't good or didn't work at all, or they were just not very well done. So maybe what I should do is capture this screen, and what I'll do is I'll insert it at the end. Now, one thing I will show you, I will also include at the end, I took pictures, okay, and you can zoom on your screen, and then you can trace the wires if I went too fast with what goes where, and as long as you match the wiring and you have everything wired correctly, you shouldn't have a problem uploading any sketch to this Arduino, but mainly the one I made. And if your unit does not want to it's not strong enough and it's making this funny sound, just give it a little time. Sometimes what happens is that when the program is running, what happens is that it tries to lower the power to these two motors, and from moving basically too fast, okay? Because when it makes a turn, what happens is that it has a hard time keeping track how far away it goes. So basically the program is lowering, let's call it the speed, which would be the voltage, a little bit, and to make it so it turns slower than normally when it runs, okay? So if I happen to make a better version of this program, then I'll upload it for you guys and put it back into the same place. So I'll add on the end of this video the screenshot, so you can see where I go, where is my basically GitHub storage space. Okay, I hope you have as much fun with it as I did, and some frustration is not a bad idea, because that's how we learn. And I wish you a great day.